Now let's learn about Swift strings. A string is fundamentally the way you interact with the customer. So the customers read text, and you often need to insert some data into that text before you show it to them. Some naive architectures pass strings back and forth from the client and the server, and you may have to integrate with some of those. Obviously, JSON and XML are sent as strings, but you convert those really into objects. But fundamentally, you're working with a customer and you want to provide feedback to them, but you want to create that string on the fly from your program code. Let's take a look at how we do that. What we'll do is we'll start up a new playground and we'll see how strings work. All right, we have a string put in for us already by the environment, so we'll print that out. And as you know, these playgrounds run automatically. We'll see the output down here. And there, it printed it out. It also shows it over here on the right, so we can see. This is pretty cool how Playground shows what the variable's value is. And so if we wanted to make a long string, we might go a lot of information here. We could use some of these special characters to make it have a new line. And you may know that this carriage return line feed has a long history going back to typewriters, where you had to return the carriage of the typewriter as well as scroll up the typewriter one line. So you had to send two commands. And so if you were in Windows, then you would have a carriage return and a line feed. But that's been kind of truncated in the Unixes and iOS to just have one character. You can see down here that actually printed out. Each of those was processed as a new line character. So we just have the carriage return now. And if we're working with Swift 4 later, now that we have a pretty cool feature, we can actually use these triple quotes and just go to town typing on many lines. And you can use some special characters high. So normally the quote would have to be escaped, but you don't have to if you're in this triple. And you can use, can even add extra characters. See this right now, I'm not on Swift 4, so this particular syntax doesn't work. And so if I wanted to have a string with a quote, I'll have to do an escape. So that's your typical way of putting special characters in, is putting a backslash before them. And this one's already here. It had that variable with the same name. And so we can see over here, it'll put the quote around our word there. Now, where it gets interesting with Swift is it's more of a modern language that it supports Unicode. So Unicode was an effort over the last 20, 30 years to encode all languages in a character set. And so they have this character set called Unicode. And Unicode, the way that it's implemented with Swift is they have something called graphemes. So graphemes are parts of a character. And so you may know about accent marks. So an accent mark is a grapheme, and a letter is a grapheme. So you may have something like a acute mark, and we'll show that in Unicode. Basically, there's a Unicode number that represents each character. So we're going to say Unicode, and then we'll put in the number. So in this case, it's a hexadecimal number, base 16, and then when we have this processed, we'll see it is E with an accent mark. So That's a Unicode for that accent mark, but also in Unicode we could put the graphemes together. So we'll put two Unicode code graphemes. So we'll do one for 65. Let's see what that is first before we proceed. It'll compile it and it'll show us that's actually just the E. So that's the regular letter E. And then after that, we're going to put a different Unicode character. And this is going to be the accent mark. So this accent mark doesn't go next to it, it goes back to the character before. So see, looks pretty much the same. Basically, as far as Swift is concerned, these are the same character. So we can say if this character is equivalent to that character, in Swift the equivalence does do string comparison, so it's not object equivalence. So you don't, unlike some other languages. And then we'll just put in what they are. Exception here. I'm sorry, these are type characters, so we can't do the equivalence. You can create strings out of these and check. There we go. So I'm sorry, at that point we're working with characters, so now that we create them as strings, we can check and see if that works, and it does. So they both are equivalent as strings. And let's just do it a little, pull this out so we can demonstrate one more point. All right, so this runs and we'll get the same thing. But what we're seeing here is these are two different objects, two different strings, but they both are the same string value. But you could do something like the triple equals, that checks for object equivalence. And this is a kind of fine point, but it's kind of very, I guess, fundamental. And this is not allowing me to check the strings because they pass by value. And so by definition, they're not going to be equivalent. So by definition, they are different objects. So if we created a class string holder and put a string inside of it, and then we create a few of those. I use command / to comment that out, the block out. And then we'll say the object 1 let's go ahead and pass that in. So we're going to pass it in, so we need an init method, because that is the method called when you do the construction, so the constructor method. I'll just say that in the object. The semicolon there. And then let my string is going to be a variable because we're going to change it. So let's make it a variable. And then we put our label in here. We didn't do it sessionally. Okay, so now we're going to pass in a string, and it's going to go ahead and stick it into that member variable called string. And let's create a second one. We'll create an object 2. And now we can check and see the equivalence of these. So we can say if object 1 is the same object as object 2, then we'll print the same object. So we can see those are not the same object. But here with object 1, we'll see they are the same object. And so the point is, the strings by definition are not the same object. What that means is that if we take a string and refer it to the same string, so we make this variable var like this, and we were to put it in here, if this were if they were allowed to evaluate using the triple equals, if they were derived from any object, then we would see that they're not equivalent. They're actually copies. So every time you create a string, it is a copy of the data from the other string. And so that's kind of an important point. If you call a function and pass in, like here we call the init, we're passing in this string. Now these are actually different strings. They're different objects. And a copy is made and stored here. So like with some other languages, with strings being immutable, you can end up with several strings being created when you think there's only one. So that's always a performance concern. There's some optimization in Swift to not make copies when it's inside a method call until it's actually needed. But let's move on. I guess some of the other special characters that we might want to try to review and just know about is kind of the null character. So let's see what that prints out. I'll print out pretty much nothing because it's an empty character. See what else we can do. Make a couple of these and we'll print out several of these special characters. Just kind of see what they are, see what they do. Backslash itself, if you want to print out a backslash, you need to escape it with another backslash. If you want to print out a tab, backslash T. These are the same as a lot of other languages, but you know, just good to know. Line feed, backslash n, and then the carriage return, backslash r. For purposes of Swift, they'll be both working for us to give a new line. And I guess even NetWare did it backwards. Instead of carriage return line feed, it had line feed carriage return. So just a little bit of trivia. And then, yeah, the Unicode. We've already seen putting Unicode characters. So let's see those basically put out. We get a tab with the tab character. We get some new lines. And then down here we have our double quote. So just some of the escapes that you'll have to do if you want to show that character. Because we're using Unicode, we can show also some symbols, some emoji type symbols and other symbols. So it's kind of interesting to put to type those in. So we might be able to put like a circle, Unicode. See, what is the circle 20 DD? And that's going to be a character. Because the way we're typing in, it doesn't know. See, there's the circle over here. The interpreter doesn't know that that's going to be a string or a character, so we have to declare it as a character. And then we can just put some other thing here, like a letter C or something. And with Unicode, you can kind of build up the character using these graphemes. So this is just one way that you could come up with this encircled character. And we just put those two together, and we can make an encircled character. Let's see what that looks like. Yeah, so there's our copyright symbol, just an encircled C. One way of doing it, obviously, there's other ways. You could even put the special character in, copy and paste it. So with Unicode, if we look over at these code tables, we can see that Unicode has code tables for each of the hexadecimal numbers, what they map to. And so you can kind of go through and figure out what are these graphemes and could build things up if you actually needed to. It's a little bit more than you probably would need to do. What you'll be spending most of your time doing is actually concatenating strings. And so you mostly will be adding these together. So if you want to put out that entire string, you can put out the greeting, and you use a JavaScript style syntax where you put out, where you add in, you use the plus sign to concatenate strings, and that'll do it. Or you can use Swift syntax, which also can be used for adding in objects, which basically just uses the backslash and then the object escape. So this is kind of convenient if you can do things that are programmatic also. So in this case, kind of simple. We just printed it out, but you might want to do some additional math here, like 2 plus 4, and then put it in. You know, actually can run a little statement inside your string generation. There we go. So you can see we get 6. So you can. This is just a kind of quick way to insert a little bit of code inside your string creation function. So kind of cool little thing you can do with Swift. Let's see what we got over here. Let's say I copy a symbol. Like copy this symbol. Can I just put symbols in here? Print. See what that does. And yes, it does just print symbols. So that's kind of pretty cool. You could just copy in some symbols. You could do it with the Unicode characters also if you wanted to. So we could do let's see, for USA, it's 1F, 1FA, followed by another Unicode of 1F, 1F8. Okay. Finish that. Yep, so that's two flags. So either one of those does the same thing. I'd like to put UK, so that's US. Wonder what is UK. So the first one is U. Let's see, what is the next one if we do K? Let's see, S would be like E or F0. Let's see what that is. UK. Well, see, that one didn't get interpreted to the flag character. And so I'm curious why that is. So I'm going to go over here and try to figure it out. See if we can find UK. Is there a flag? Is that UK there? Looks like UK. So let's set a character let UK. We've got this UK string, I guess, string of characters. And then we're going to print it out. So for char, and look at each character in our UK string dot characters. Hit escape and it should do the completion. No, it's not doing it for me. String dot characters. And in Swift 4, you don't even have to put the dot characters. So that's kind of an improvement for Swift 4. But let's print out whatever we got here. What are each of these characters? Let's see. Telling me I have an issue here. It says expected comma separator on my character. We don't even need the parentheses. Let's take that off. For the character, which is a character in UK string characters. Okay. Oddly, that now compiled. And it looks like it just printed that UK string character there. And so, yeah, that is the one character. That character is a combination of those lexemes. So what we want to do is say, well, what are each of those lexemes, or we call them code units. And so let's do it again. This time we're actually going to look at, break the string down into its Unicode scalars, they're called. So those lexemes will go like this, and then we can print out exactly what are the pieces. Print code unit. Let's see if that does it. Oh, okay. So now we can see why the flag didn't work here, why we were getting UK. We were getting UK because we were printing the letters U and K, but the flag character is actually GB. So we'd have to come up with a GB here if we wanted to do it with Unicode letters. So was that 1F, 1E, C? It's a different flag, and then E7, I think. It's E7. See if that's it. Yeah, so that's a way of breaking it down. So now what you can see is not only are strings made of characters, they're also made of some Unicode scalars, and that allows you to kind of break the string down further if we're working with Unicode. And we can see that we could even break them down their UTF-8 representation of the Unicode character or the UTF-16. So it would be interesting to see, are these all the same length? So let's print out their length. So let's just go through the paces here for each one. So characters, which is kind of what we're accustomed to working with, like in JavaScript and other languages. And then we'll print out the UTF-8 and 16 count. And these scalars, we'll see they have some different amounts. So there's only one character here, which is the flag character. But if we were to have to represent it as UTF-8, that would actually take up 8 characters. UTF-16, 4 characters, and then the hexadecimal here is only takes up 2 characters. So just a way of representing it is, would have different lengths. Just something to kind of be aware of if you start having to process Unicode. Now let's move into a little more just pure string manipulation. I guess, well, one more kind of interesting point for this Unicode is we have a letter A in Unicode. So that letter A, set it to Unicode letter A, and then so we got our, in other languages that also have a letter A, well, it looks like a letter A. So let's see what it looks like, and it shows it over here on the side. Yeah, these both look the same. Would both look like A's to me. So that's the Cyrillic alphabet. Well, we can go and check and say, if letter A is not equal to this one. So if you really want to trick someone up, you can use that Russian letter A in your writing. You can really mix them up. And let's see what it says here. It's a case where I need to use the escape, because it's not interpreting that character as a string, so it doesn't know how to add it. Not the same A. So, you'd really, people might visually see the A, but it may be a different letter. So strings have various functions we can use to work with the string. If we go back over here to our string class, we'll see it's a class in Swing, and allows us to have some various functions we can do to manipulate the data inside. Now, strings in Swing are using indexes, and they use have a start index, an end index, and so these are actually index objects. So we'll print the type of it, and we'll say start index. Well, that didn't do what we wanted. Okay, let's see. When we print the type, we'll see it's actually an index type. So we can't do something like you could do maybe in another language, where you can go greetings of 0. Because these are not 0 indexed. And the reason is, if we go back to what we just reviewed with the Unicode, is that there really doesn't make sense to say sub-0, because we don't know, are you talking about the UTF-8 representation of it, or are you talking about the Unicode scalar representation? So because of that, we use an index character to move through the strings. So we would be more likely to do something like let char0 equal greeting start index. And that way we can get the H out of the greeting, which was hello. We can look at the end, for the end index. Now we would need to offset that by some amount because we need to go back one. So that's one past the very end. So we would need to offset that. So what we can say is we can get a index. So a string, we need the index of what? We need the index of the end index, but we can offset by -1. So we want to go one back from the past the end. Typically in strings, the end index is past the very end, and so we need to go back by 1. And so let's break this out and see how to do it here. We have an index. It's going to equal, what we're trying to do is get the greeting index here. And so want to get the greeting index starting with the end index, but I forgot to tell it which index. End index, obviously, is the one for greeting. And then we're going to offset it. Let's see what it has here. It's telling us undeclared type index. For now, I'll just let it figure that out itself. So it's an index, and then the character on the end is the O. So if you put it in greeting object, find its end index, and go back by 1, that would be the last character. So generally the end index is at the very end, and it's kind of string terminating. So it gets interesting when you work with strings. They're basically treated like arrays or dictionaries are in Swift, and you have these index objects for moving around in the array and selecting something in the array. Same case with the dictionary. So you can use these same index objects with those data types. So let's add another index. Let's just say print. Let's just do this. Since we're starting with 0 on our index number, I'm just using index 1 for the second character. So let me go greeting. We get an index to the second character. We'll offset it by 1, so we'll go to the second one. And now we could print that range. We could print an array that starts with index 1 and goes all the way to our last index, which was at IDX. So that should prints out these index objects. So position 1, position all the way through position 4. And we see it's a range, so that's giving us a range object. And we'll look at those in a minute. That's a way of working with a character subset within the string. One way of creating strings is by using the repeating method. So we could say, let's create a new string, and it's going to be repeating. We'll put in a string, repeat this, and then we'll tell it how many times. Let's repeat that 3 times. So that'll give us a new string. And let's create another string here. And we can check and say, is there anything in there? So is empty is the method to check and see is the string empty. And we'll see whether or not these are empty. I misspelled repeating. Okay. So now I've got a string that repeats 3 times. And this one is empty. There's nothing. It's empty string. And the next one is not. So just a few methods to check and see if the strings are empty or not. And we also have some ways we can do a quick check on the beginning of it. So it has prefix. And this takes it by position. So does this have the prefix of ha? Let's see. Our string have that prefix. When that runs, we'll see. Yeah, it does have that prefix ha. Look over here. The prefix, the beginning is ha. And then we could also check the suffix. So if pada has suffix, and we could just say aha. It has that suffix. Then we'll print ha. Aha. It has both of those. And it runs. Yes, so we do see it does also have that suffix, aha, on the end. So these are kind of quick ways to check and see if what your string begins and ends with. I'm going to do a quick check. You can also convert things to uppercase. So notice I'm passing, the result goes into a new object here. And we can do a lowercase as well. So just a way to quickly converting to uppercase, lowercase. So we want to do string compare. Sometimes you want to do it that way or tell it to do it case insensitively. We can also cut off pieces of the string. So we can do ha. And we can drop. Drop the first character, for instance. In Swift 3, we still have these characters. We drop first, and we'll see that this has dropped the H off the beginning. And then we could let the, and also do the head. And you could even tell it how many characters you want to drop, drop 3 characters off the end. And we'll see when it evaluates it, that this comes out, is the last, I guess the first 3 characters. We dropped off these last 3. So just some more methods that you can use with string. And now getting into the range, let's use the range function. So the range, we're going to say, do we have a matching range in here? So this is how we do a search within the string. So we're going to look for a range of, and we're going to look for aha in our string. Starting from the back. So we'll just decide to give it that option. We'll go from the back. And if we have it, we're going to print out our range of match objects. We'll see what we got as far as our match. This basically says, let's look for a string within our string. So this is your substring search. And we can see, yes, again, we have this range. Up here we had a range. Again, we have another range. And then we could use that to do some more string manipulation. So we can go over here to our characters, and we can go and say, give us the prefix. At this time, we're going to use what we returned from that range, so where that matching string was. and we're going to go to its lower bound. So where did it start? And we'll print that out. We'll also print out our range of print out the characters that are in that range. So now we can see that this actually is an indexing object, and so we can actually pass it into our string, and it will give us back the match on that indexed object. So here with the suffix, we just got all the way up to where that range is matched, and here with the range of match, it actually gives us from that strings, think of it as an array of characters, it gives us the strings matching in that range. So that's how we can go and search for substrings and extract them. So here we extracted the substring, and here we kind of extracted to the substring. Instead of storing an index, you store this range, and you can use those type of index characters. You can create a new string, be a copy of this one, and we're going to append to it. So append is a way of just adding to the end of the string. So now we'll see, it just takes and adds some more strings on the end. So add some more characters. So that's a way of kind of building up characters. So haha. And this one we'll look for a range of. We'll look for where's this character set in here. Where's this little substring, and then you can do this. You can remove also within a string using that range object. So we'll remove a subrange inside of our string, and that's going to be our range match. So using that range match, we're going to remove something. And in this case, it's not quite sure that that's going to be valid. So we're running an optionals issue here. So we have a let, but it's not sure that's going to be a valid object. We'll just say, yeah, we're sure it's going to be valid. And, just because of the way we're typing this, we know it will be. So we're not going to check first. And let's print then what we have. So we can see that we had the characters, then we used the remove subrange. Passing in a range allowed us to remove some characters from it. Okay, so pretty cool. Got all these methods for finding strings, working with the indexes, getting the characters out, even removing parts of the string, matching parts of the string, and now we can do an insert as well. So I'm going to insert some characters here. So this characters, and I'm going to insert them where? I'm going to insert them where we had this match over here a minute ago. And then it's going to be the lower bound. So we'll insert them down there where that started. And see, now we've inserted the PPY and kind of changed our string a little bit. So it's just another way of working with the characters. And I guess the summary point here is initially Swift characters are fairly easy. You can have strings and you can add strings together. But they're really more complex because they support Unicode. And because they support Unicode, we work with these index objects in order to manipulate them. So we have special methods to find matches, find the range in there, special methods to remove and insert to that string. So it becomes a little more complex to work with them. And a summary point also is that the strings are value objects. In Swift, they call them value objects. They're immutable. If they're passed around like to other methods, then a copy is made. So you're not passing an object reference. And that's about all there is to Swift strings. And have a happy ha 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 time working with the Swift strings.